Offshore freshened groundwater is a term that we use in the scientific community that refers to water that is stored in the pores of sediments and rock fractures beneath the ocean floor that has a salinity which is lower than that of ocean water. Compare this to traditional groundwater resources. This refers to water stored in rocks beneath the Earth's surface on the land that you would typically access in a well that you would see on a farm or on some land where you would drill down and you would access the water table and you could pump this water for agricultural purposes or for home usage. This is a traditional way of accessing groundwater. Offshore freshened groundwater is considered unconventional. It's not the usual place that we look for freshwater resources.
So potential applications are as potable water, since people all around the world have an issue with and a scarcity of potable water. It can be used in agriculture. It can be used also as industrial water if treated necessarily.
And we know also that a majority of the population lives in coastal areas where they need water. They need water for the cities, for the everyday life, and of course for agriculture. And we still have to look how much groundwater is there, but it's definitely a resource of potable water. But there are still a lot of gaps in knowledge. So we need to develop methods and modeling tools to assess that.
So we are here on a field which is equipped with boreholes in order to study some aquifers that are lying here below our feet. So you can find fresh water at about 80 meters below the ground in this place. And right below, 50 meters from here, there is a sea. So this aquifer is exploited for freshwater purpose. And of course you can imagine that it is recharged. The water is coming from that part when it's raining. It's entering into the ground and it's coming down to our feet. But it doesn't stop at the coastline, which is like here.
Well, the first thing is these systems are connected to land. We don't know the extent. They are the big unknown, especially the coastal area. Until now, the studies finish on the beach. We are just starting to explore this wide ribbon, this unknown area, and we don't know how deep they extend. These systems are not infinite, and they can be two types: the ones that are connected to land, or the ones that they are fossilized. If they are fossilized, they are not sustainable, and then we have the same problem we had with the oil and gas industry, that the moment we tap into them, we exhaust them. If they are connected to land, then we should study them and see if how much water we can extract. The same for the other ones. But there are also some implications that I think are important. It's all the geohazards. Like, for example, the moment we extract water from the subsurface, we're going to have some subsidence, and we can trigger also earthquakes by motion of faults. So we have to be really careful in that sense.
Offshore freshened groundwater is considered unconventional. It's not the usual place that we look for freshwater resources. However, it has been proposed that in coastal regions where you have very high water stress, this can be a potential solution where you can tap into these reservoirs either in offshore installations or from onshore installations that extend offshore. And we could use this as part of a solution for water stress, particularly in coastal regions.